Hello. Well, thank you for coming. I don't want to forget that. Thank you for coming tonight, June 8th, right? So we're right in the thick of things. It was hot last week, it's cold this week. So, we're all cooling down, right? So, but anyways, I'd like to thank you for coming. My name is Joe Hart. I'm your chapter leader here at AZSSUG, Arizona SQL Server Users Group. We are a past local chapter, professional association of SQL Server, which means that we're part of a global community. So we like to reach out and find anybody that can speak for us. That's what we have today. So I will talk a little bit about past community news. Not much going on right now, but in October, is it called? October?
Oh, past is October.
Past Summit is October. So we will just go quickly over that. If you haven't heard of Past Summit, it is the largest get-together of past SQL Server professionals. I think there were over 5,000 last year, which is awesome. So I had the pleasure of going last year and representing our chapter. Connie's going with her company, which is
International Cruise and Excursions.
International Cruise and Excursions. Jeff Schmidt is part of that group. He's hey Bill, yeah. So their whole crew is going, so it's really, really exciting time. It's just like SQL Saturday. If you guys remember, we had posted one here. So for 3 days, you get sessions from SQL Server professionals from all over the world. So it's quite crazy. Had a good time. You get networking opportunities, and you get to speak with the industry leaders. So the discount code is for us is LC15MHD6. So if you don't write that down, email me and I'll get that to you. This is 150 off registration. And I don't know what it's at right now, but it always goes up, 1 month out, 2 months out, whatever it goes, it starts getting more expensive as you get closer to that. So I will be going, Bill, you going there? Maybe. Jeff and a lot of their crew is going. So anybody else deciding to go out there? Yeah. So pretty exciting. Talk to me before you go because we can get together and hang out. So pretty exciting stuff. We always have virtual chapters. I have never been a part of one. Anybody else out there has a virtual chapter? Matt, what do you think?
It's awesome.
There you go.
Great to meet you.
Yeah. So virtual chapter, you can just go online and be a part of that group too. It's just like here, but they have specific, looks like dives that you can go in there. So pretty exciting stuff. Here's the virtual chapter list that's up and coming. Of course, Global Spanish is tonight, but the rest you can check out online. The schedule's online. So, okay, like I mentioned, SQL Saturday was our big event of the year. We had 400 plus attendees, which is awesome. Great job, teams. These are the ones that happened on June 4th. Look on the calendar and see where you want to go and where you want to go experience SQL Saturday. I didn't put on here, but I'm going to the Albany User Group, which is July 30th. So I started that user group, so pretty excited to go out there and speak out there. So, and I think we heard you. And then also we have International SQL Saturday. So pretty exciting. I think, Tim, did you just go to one in Florida?
Yes, Pensacola.
Cool. How did it go?
Yeah, that's one you definitely need to have on your radar. If you get to go, a small group of us got together Friday, went scuba diving. Saturday we had the free day of training, which was fabulous. Sunday, a group of us chartered a fishing boat, and there's about 27, 28 of us. Went out and spent the day deep sea fishing. So it's truly an opportunity to get to network with your fellow SQL family and spend time together at the beach. There's worse things you could do with a weekend.
There are experiences that you can experience with SQL Saturday, and I'm trying to go to the San Antonio one. I'm trying to make it out to Nebraska, my home state, and go to that one in December and November. But try to make a list of them next year. I know I have not been to New Mexico and I want to experience that one. So California has a couple, so let's go as a group, if we can contact each other, we'll have fun. So it's all about networking and having fun and experiencing and learning new things. So stay involved, contact me. You can contact me through Meetup, Meetup group. We also, have our Arizona SQL Pass.org site. We have our Meetup site. We have a LinkedIn group, which I don't keep up to date, so I probably should do more of that. But, that's how people find out about this group. We have a lot of people here tonight because, some of the people found it on Meetup, so, or somebody's called me, but, so without further ado, we have Tim Radney. He's a SQL Server MVP. He's a principal consultant at SQL Skills. He's done many talks, and let's just go ahead and see if we can get him presenting.
So do I have to speak to make it?
Yeah, here, let me go ahead and see if now I can move. Let's see how we're going to do this on the screen. So I have you up, Tim.
Okay.
Just, I need to put it on my second screen, so here's a second. I can figure that out. Let's go in. I wonder if we can go ahead and do this and I wonder if it has, does anybody see like a full page mode? I think there would be. You might just have to let it go like that.
It's the one on the top bar on the left side.
Like that.
Yeah, mouse over the presentation. And then just go left.
My left, your left.
No.
This
On the presentation.
one right here?
No, the icons and here at the top.
This one?
There you go, there you
I'm not sure. Yeah. It's kind of
go. We're all there.
So I think we're just gonna go here. We're just gonna show this. Sorry, it's not full screen, but the viewers at home are seeing full screen. So. Ooh, hey, that's better. F11. Oh, that's okay. So I think we're good. So Tim, like I said, Tim is gracious enough to get on today, and Tim, I'd like to thank you personally for doing this. I know, when we reached out to Paul Randall and Kimberly Tripp, they said, this guy's gonna do a good job. So I'm really excited. Tim, like I said, you're a principal consultant, right, at SQL Skills, right? So, Tim, I'm gonna go ahead and let you take it away. Thank you for. Thanks.
All right. So this is common SQL Server mistakes and how to avoid them. So I don't know if you need to mute because I'm hearing like feedback, hearing myself coming through. All right. So this is common SQL Server mistakes and how to avoid them. And we'll get started. So I'm with SQL Skills. We're a team of world-renowned SQL Server experts. I kind of like to say that my team is, and then there's me. But I get to work with Paul Randall, Kimberly Tripp, Glenn Berry, Aaron Stellato, Jonathan Cahias. We do instructor-led training, which we actually have a class starting up next week in London. Actually, I believe we're going 2 weeks back to back. We do online training through Pluralsight. On our consulting side, health checks. We do everything from hardware, performance tuning, upgrades. We also do remote DBA, or have a remote DBA service where we do system monitoring and troubleshooting, basically SQL skills on retainer. We present at conferences such as Past Summit, SQL Intersection, and kind of the cool takeaway here is you should become a SQL Skills insider. You can go to sqlskills.com/insider, and Paul sends out a newsletter every couple of weeks that has some really cool little SQL Server tidbits, an insider video where we record some how-to topic. Usually those last anywhere from 3 to 8 minutes. So no spammy markety stuff, just kind of cool things happening within the SQL Skills team and some SQL Server tidbits. I spoke about our immersion events. Like I said, we have one coming up in London. We do these things all over the world. The remainder of the year, I believe, is London, then Bellevue, and then back to Chicago. So IA0 is our accidental DBA. IA1 and 2 are the performance tuning 2-part series. Our IHADR is on high availability disaster recovery. Just lots and lots of cool stuff. And you can check that out at sqlskills.com. Training. And so who am I? As was said earlier, I'm a principal consultant with SQL Skills. You can email me, Tim at sqlskills.com. I blog at SQL Skills and my personal blog, although I don't think I've blogged there in about a year. I am a Microsoft Data Platform MVP. I run the local Columbus, Georgia SQL Servers user group, and more stuff on the slide. Kind of the takeaway on this one's the bottom line. I like playing with electronics, aquaponics. I farm chickens, goats, and tilapia. And after this weekend, I'll have some mini Scottish Highland cows. So kind of taking the farming thing to the next level. I mentioned Pluralsight. If you'll email Paul at sqlskills.com with a subject line user group, Pluralsight code, he'll send you a code good for a 30-day trial of all the SQL Skills content on Pluralsight, which we've added like 4 or 5 additional courses so far this year. Hopefully mine will be ready at the end of the month. So what is the topic? What are the things I'm going to talk about? So in my, gosh, going on 12 or so years as a dedicated production DBA, one of the things that I have encountered working for clients all over the world, I kind of started my career in SQL Server with a fairly large regional bank. And through that, I continually inherited systems from other people. So I quickly put together a checklist of what are the things I need to not assume and go and take a look at and fix. And what's odd is I continue today to find the same common things, either misconfigured or not configured out of the box on SQL Server. So we're going to talk about backups, consistency checks, log cleanup, statistics, index maintenance, memory settings, max degree of parallelism and cost threshold for parallelism, TempDB, SQL Server alerts, and lastly, power savings. So I always start with backups because as a production DBA, there's really nothing more important in your job than being able to perform data recovery. In order to do this, you have to have proper backups and recent backups. So what do I look for when I inherit a new server or I'm taking a look at a server for a client? Is do they have recent backups and are they adequate backups? So to kind of get started, I don't really look at a backup strategy. I like to talk about what is their restore strategy and what does it need to look like. And you need to plan a restore strategy to meet certain service level agreements, such as how much data can you afford to lose and how long can you be down. So that's your RPO and your RTO. Depending on your service level agreements will determine the type of backup plan that you put in place. So if you can afford to lose 24 hours worth of data, then a database and simple recovery model and nightly full backups or weekly full daily differentials will be sufficient. However, if you have an OLTP database where data is continually changing, which most of us do, then you really need point-in-time recovery with maybe 5 up to 15 minutes of potential data loss. And with that, you need a database in full recovery and log backups every 5, 10, or 15 minutes, depending on your SLA. And so those are the things that I look for. What I tend to find is log backups every hour or 2 hours, or not at all. Mission critical databases and simple recovery, where the client could lose up to 24 hours of data. So you need to have your correct recovery model, and then you need to have the right backup process in place to meet your service level agreements. So what if, for example, you have a multi-terabyte database that's mission critical and you need 15 minutes or up to 15 minutes of allowable data loss? Well, from a backup perspective, you can do log backups every 15 minutes, nightly full or weekly full and daily differential. However, if you had an RTO, recovery time objective, of 4 hours, can you restore from backup in less than 4 hours of a multi-terabyte database? Probably not. So in that case, your recovery plan or your restore strategy, you're going to have to implement some HA technology. Either have an availability group, a mirror, a logship replica, something in place that can help you achieve that uptime. The other thing is validating backups. I usually ask this either on a scoping call or through a questionnaire, is how often do you restore your backups to validate that they're good? And most of the time, the response is either not often enough, once a year, or we don't. So with that, the absolute best method to validate backups is by restoring them. And it's so simple nowadays to have a dedicated environment that's relatively close to production specs to do this process. And you can script this out using PowerShell. You can C# and get an app dev person to write you some code. I mean, it's pretty simple to kind of loop through all your production backups and restore them to a dedicated server. You can get a virtual machine stood up. You don't have to have production specs or storage. Get as close as you can, but cost is usually a factor. And at least test the restore. By testing the restores, you get a decent idea of how long the backups or the restores would take. You can generate reports off of this database from MSDB on which backups were restored, how often, how long it took, those types of things. And you can present that data to auditors, regulators, examiners, those types of people if you're in a regulated industry. And that really kind of helps get them off your back, showing that you do this stuff fairly frequently. And you could also, if you wanted, could run CheckDB on these restored copies as well. So I always like to kind of make it available, a script that I tend to use when I'm working with somebody through forums or emails on, hey, run this script and it will tell you the database name, the recovery model, your last full backup, your last differential if you're taking them, and your last 2 transaction logs. And from that, you can quickly tell a lot of information. Do you have databases in full recovery with no log backup? If you do, then in that case, you have a transaction log that's continuing to grow and will eventually fill up the disk drive. And second is, what is the time differential between the 2 transaction log backups? That will tell you whether you're backing up every 5 minutes, 10, 15, and so forth. So I can tell what your transaction log schedule is like. So there's a lot of information that you can do. Do you have a backup that's weeks old? Has it been one recent? All that you can tell from the script. So most important thing, proper backups that meet your service level agreements. And don't ever assume when you take over a server that this stuff is being done properly. So where I go next is a check for consistency checks. Now, with backups, that one's kind of a known. I mean, even if you're an application developer and you're also responsible for SQL, you kind of get that you need backups. But if you're not a full-time production DBA, you may have not ever been made aware of consistency checks and running DBCC CheckDB, looking for potential corruption. So unfortunately, I mean, corruption happens. It's one of those situations of it's not a matter of if it's going to happen, it's a matter of when. And what we have found is 99.98% of the time, this is related to some IO subsystem problem, something at the disk or the transport to the disk, a HBA faulty, out-of-date firmware, caching technologies on SANs. I mean, so many things can happen as your data is being written to the storage. And 0.01%, it could be isolated local hardware or a SQL Server bug. It's rare that SQL Server introduces a new bug that can cause corruption, and when it does, it's been very quick to be fixed. And like I said, it's very rare. So what do? How do you find or check for corruption? Well, the simplest thing is running dbcc check db. You can also run dbcc check alloc just to check the allocation pages. You can check just the catalog. And if you have a very large database that's been partitioned into multiple file groups, you can get granular and check individual file groups, which is quite nice. If you have a multi-terabyte database, you have read-only file groups. Once you've checked or run check db, and you have a good solid backup you can restore from, you don't have to run checkdb as often on those read-only file groups because you have it backed up and you have something you can restore from. So you can just focus on checking the read-write file groups. So you want to schedule this to run as a SQL agent job. And how often? Most of the time I see this being scheduled once a week. And the important takeaway with how often to run is you want to make sure that you have backups that go much further out than your interval for running CheckDB. Most of us, we keep at least 14 to 30 days worth of backups. So if you're running CheckDB once a week, then you have at least a full week of backups from the potential corruption. So if you do your fulls on Sunday, but you're running CheckDB on Saturday, so if you don't run CheckDB, so say you run the CheckDB on Saturday, the corruption happens sometime on Sunday, you wouldn't detect it for 6 full business day or 6 days until CheckDB runs again on a Saturday. Well, as long as you have backups dating prior to the corruption, you can restore your full, your differential, and then all the transaction logs, because the corruption would have happened somewhere at the subsystem level. So your transaction log backup should be consistent. So you can, most of the time, recover from backup with 0 data loss, as long as you take immediate action. So when CheckDB fails, don't wait, don't put it off, don't ignore it for a period of time. You want to immediately take action by looking at the error, probably running CheckDB again to make sure that it wasn't just some random fluke, and then take action. Many times the fix is a restore operation, which is why you need to react rather quickly. But a lot of times you can get lucky and it's a corruption in a non-clustered index, and you can just drop and recreate that non-clustered index. However, if it's your clustered or your heap or something within the metadata within the database, GAM, SGAM, PFS page, you're going to be looking at a restore. All right, enough of the gloom and doom with backups and potential data loss. Purging logs. So I talked about backups and MSDB. MSDB stores all backup and restore history. So all the data related to when the backup ran, how long it took, the file group or the backup media set, the location that it was written. I mean, all that stuff is stored within MSDB tables. And most of our third-party tools and the common scripts out on the internet, such as Ola Hallegren's maintenance solution, have procedures in place to delete the backup history. However, if you've rolled your own solution, then you may not be deleting that backup history, and MSDB will continue to grow and grow and grow. So built in is sp_delete backup history, and you call that stored procedure and pass it a date. Anything older than that date will be deleted. So it's real simple to take this, throw it into a SQL agent job, declare a date time variable, you execute sp_delete_ backup history, and pass it that parameter. So you could do get date minus 30, 60, 90, whatever time period that you want to keep, and then have this job run on a daily basis, and it will help keep MSDB much smaller. And there's a lot of other things within MSDB that you want to make sure that you're purging, such as log shipping history and service broker. I mean, a lot of other things. I've got a SQL performance article out there about maintaining MSDB size. And then there's a lot of comments in there that people have posted additional things. But for me, backup history is the number one culprit for bloating MSDB. Then you have your SQL Server log. So many of us have to go in and look at the SQL Server log. That's where we go to see if there's been any errors reported, login failures, deadlocks, things like that being written to the SQL Server log. But out of the box, SQL Server only recycles that log every time SQL Server service is restarted. That could be months. So when you go and look at the log, you have months and months worth of data in there, and it could be hundreds of thousands of rows. So it could take minutes, several minutes for the log to load, and then you need to go and apply a filter to filter the things out. That takes additional valuable time, and it really kind of clogs up the SQL Server log. So what you can do is execute sp_cycle_error log to force a new log to be generated. So this is brilliant to set up, again, in a SQL agent job and have it execute at midnight every night. And so every day you get a new log for that day. And so when you need to go view the log, if you need to view 3 to 5 days, you just select each one of the days, check the box. It's part of the view, and then you can apply the logs to search for certain events. The problem with just increasing, the problem with recycling the log is SQL Server by default has the active log and 6 additional rollover logs. So if you're cycling every day, that's only 7 days. So you want to increase the number of the default value from 6 to another number. And as of SQL Server 2014 and below, that number is 99. So that's the max number. So set it to 30, 35, 40, something so you can at least have 30 days worth to go back and look at, and you'll be in much better shape. And I have seen some clients, they set it to 99 just because they can. All right, statistics. Another big area that I'll look at are my clients keeping their statistics up to date? I want to say, probably always, have a process to manually update your statistics. Now, Ola Hallegren, I mentioned him earlier with the backup solution and how it can do. Yes, sir.
So right now on what I'm working on, when we deploy code to dev and SID and QA, we're always having trouble with QA because the stats aren't updated. So it is a problem within our environment, and I don't think the DBAs realize that they need to, or we just need to take it that step further to actually update the stats. So we find that the queries run really slow if we don't update the stats.
Oh, absolutely. Yeah, so the organization I was in before joining SQL Skills, we put our standard SQL Server build, so whether it was dev, QA, or production, was the maintenance solution to go and update statistics, and we update statistics every single night on all databases, just because we were a bank and we had the maintenance window. And using this type of process, if you use something like the OLA process, where it's only going to update, or you can specify only update statistics that have row modifications. So if the data hasn't changed, don't bother updating the statistic because it's valid. So using the OLA process, it's an excellent process as part of the index optimize procedure. And
what version would that, or be able to do updates based on row?
I would have to go look, but I believe his stuff is valid for 2005 and up.
Oh,
so the other thing, if you're not using the OLA, you kind of roll your own solution using sp_update stats. There's parameters that you can pass to that as well. Now, unlike with CheckDB, with statistics, we do have an auto update statistics. That is on by default. The downside is it only updates after approximately 20% plus 500 rows of data have changed. So think about if your database has 5 years worth of data and it has a million rows. So 200,000 rows would have to be updated or modified plus 500 before statistics would automatically be updated. So your stats could get very skewed very quickly. And what impact does this actually have on SQL Server and on performance? Well, the query optimizer uses statistics to build the execution plan. So out-of-date statistics can negatively impact the query optimizer from determining that good enough execution plan. It's kind of like when you make decisions and you don't have all the facts, usually you don't make the best decision. Sometimes you may get lucky, but it's that whole hindsight. So providing the most up-to-date statistics usually has the much better results, so the query optimizer can generate the better plan. So how do we fix this? Updating your statistics manually, not relying on auto update statistics. And how often? Well, it depends, but for most of my clients, we run this process when we're updating or looking at index fragmentation, and we're updating fragmentation. So that's kind of the next slide, is not having index maintenance. So fragmentation, what causes fragmentation? Your data modifications, insert, updates, deletes. What causes statistics to get out of date? Well, data modifications. So roll these two things together. So what is the impact of fragmentation on query performance? I've got a TechNet article where back in the SQL Server 2000 days, Microsoft, they wanted to know what the impact is. So they went through and with different sized databases, different levels of fragmentation, different hardware, so all the different types of scenarios, and wanted to see what impact fragmentation would have on query performance. And what they determined was anywhere from 13 to 460% based on the size of the environment and the fragmentation level. Wow. I mean, could you imagine if you've never updated fragmentation or defragged your indexes, rebuilt, reorganized, any of that stuff, and you went through and fixed all the fragmentation and you saw a net 460% improvement in performance. I had been quoting this article for years, and about 2.5, 3 years ago, I was working with a client, and they had an ETL process that was taking 14 hours to run. Well, they kind of self-solutioned and said, we need better hardware. So I helped migrate over to the new hardware. It was a 3.5 terabyte database, migrated over, enabled compression on a couple of the largest tables that the ETL process used. So more cores, more RAM, slightly faster disk, compression on the largest tables. The ETL process went from 14 hours to 12 hours. Client still wasn't happy. Well, while in there looking at or working on the compression, I realized that the indexes, or the clustered index that I was having to go through and use for the compression was 99.98% fragmented on both tables. So that got me kind of curious. So I started looking through their jobs and realized there's nothing for statistics or fragmentation. So I mentioned it to the client, got permission. That night, I was able to go through and rebuild all the indexes and then put in place the Ola Hallegren index optimize procedure with the statistics update. I get a phone call the next day or early the next morning saying, what did you do? The ETL process is broke. And I'm like, well, that's the error. I said, well, there's no error, but it only ran in just under 2 hours. There's no way it could be working. I'm like, okay, well, have you evaluated the data? What data skewed, so I could try to figure out where in the ETL process it broke. And he said, well, we're evaluating that right now. About an hour later, they were able to go through and reconcile, and everything was as it should be. The next night, it ran in less than 2 hours, and I kept in touch for about 3 months, and it consistently ran in just under 2 hours. So better hardware, compression, all that stuff, still net improvement from 14 hours to 12. Index fragmentation and statistics went from 12 hours to sub 2 hours. So at that point, I realized, okay, yeah, this was might have been one of those edge cases, but that's all that was done. I mean, fixing the fragmentation and updating statistics. So how do we control the fragmentation? You can rebuild, you can reorganize, or you can disable and rebuild within a transaction, the index. You can schedule rebuilds or reorganizations in a maintenance plan. Now for SQL Server 2014 and below, this is true. You can schedule rebuilds or you can schedule reorganizations, and that's everything. So it will rebuild everything or it will reorganize everything. With SQL Server 2016, there's some additional logic in the maintenance plan that kind of mirrors some of the stuff that we see with Ola Hallegren and some other third-party tools, which looks for fragmentation level. So using a custom script, such as Ola's, you can go through and depending on the level of fragmentation, choose to do nothing, to reorganize, or to rebuild. So you can apply some logic. So if the fragmentation level's fairly low, a reorganization would be quicker and better. But if it exceeds a certain level, then you want to rebuild because it's a faster operation. And you can also choose to enable or update statistics as it's going through this process. So if it rebuilds, well, statistics should be updated. But if it's a reorg, it doesn't update the statistics. So you've had row modifications. So go ahead and update statistics for that data. And then third-party tools. Some of the third-party tools are pretty nice because they give you a UI, central management, things like that, as well as additional logging. Ola's process also logs, and the key thing with logging or keeping up with the fragmentation that you're having to take care of by reorgan or rebuilding is if you're logging that data, you can go in and look, and if you're consistently having to rebuild an index because the fragmentation level is so high, then you can start looking at that index to make sure that you have the right cluster key column, and do you have excessive page splits going on? Do you have the right fill factor? Those types of things to also better tune your environment. And like I mentioned, organizations that I've worked at, I make this part of the normal maintenance on every server, whether it's development, QA, or production. Just like with backups and other things. I mean, I want healthy SQL environments. So another fun thing and very common thing that I come across is default memory settings being in use. Now, out of the box, min server memory is set to 0 and max server memory is set to a very large number that a good friend of mine, Rodney Landrum, actually has tattooed on his arm, and that's 2 petabytes. So max server memory for SQL Server is set to 2 petabytes. I've yet to see a petabyte of RAM in a server. So what does this mean for SQL Server? Well, it sets SQL Server up to starve the operating system or for the operating system to starve SQL Server. So if you have some rogue process running on the OS and it's doing a massive memory grab, SQL Server could relinquish all its available memory and basically be rendered useless. That doesn't happen often. I mean, on shared SQL servers where the app and database are running together, I mean, you have a better risk. But the most common thing is for SQL Server and the buffer pool to continue to grow and essentially starve the operating system so that your M bytes available counter to the OS is less than 300 megabytes. When that happens, you see very erratic behavior on the server. So 2008 R2 and below, max server memory applies to the buffer pool only. SQL Server 2012, we had a complete memory manager redesign, and so max server memory applies to all memory manager allocations. So what value should you set for max server memory? There's a blog post at the bottom of the slide. Jonathan Cahias wrote a blog, How Much Memory Does My SQL Server Need? And he came up with an algorithm. And the algorithm is a great starting point. And it basically breaks down that for 16 gig or less, for every 4 gig of memory, 3 to SQL Server, 1 to the OS. Once you exceed 16 gig of RAM, for every 8 gig, 7 goes to SQL Server, 1 to the OS. Now that's great. Like I said, it's a fantastic starting point. It's what I used and still use today as my guidance. But monitoring that M bytes available perfmon counter, which is addressed in the blog post, is also key, especially when you start dealing with SQL servers with large amounts of memory. Think about if you have 1,000 gigabytes, and based on the algorithm, you may end up giving SQL Server 900 and leaving 100 to the OS. Is the OS ever going to use 100 gig of RAM? Probably not. So at that point, you're leaving 80 or more gig available to the OS. So you could consider increasing max server memory for SQL from 900 up to 940 and 960 and kind of dial it up to get as much available to SQL Server. So like I said, it's a great starting point. Min server memory, when I set it, I usually set it at 30% of the max server memory value, just as a little safety net. All right, max degree of parallelism and cost threshold for parallelism. A max degree of parallelism, also referred to as max DOP, default is set to 0. This means that an unlimited number of CPUs can be used to execute the parallel region of a query. This was a really big problem with big physical servers. With the proliferation of virtualization, it's very common to see 2 vCPU, 4 vCPU, up to 8 vCPU machines. So in that case, on a virtual machine, if it's only got 2 or 4 vCPU, even though max DOP is set to 0, it's still not a bad thing. On your physical servers where you have 16, 32, 40, 64, large numbers of logical processors, this can be problematic for SQL Server. So when a query tries to go parallel, it may try to go spread that across 64 threads, which is a lot of work. So the recommendation is, if you have more than 8 CPUs, start with a value of 8 for max DOP, and you can modify from there. For 8 or fewer processors, use 0 to n, with n being the number of logical processors. So like I said, with virtual machines with fewer processors, the 0 to n is what's already there. So you can consider just leaving that as it is. But for those large machines, or large physical machines, you want to consider decreasing from, or increasing from 0 to a number that's conducive for your machine. And NUMA nodes kind of come into play. So you can read the TechNet article or Microsoft Knowledge Base article to learn more about NUMA configurations and what is the best value for your organization. Probably more important than max DOP is your cost threshold for parallelism. This is your query cost or subtree cost. So if you've ever viewed your execution plan and you go and you view the properties, you'll see subtree cost listed in there. The default value is 5, and that used to mean 5 seconds. So if a query was going to take more than 5 seconds to process, or if it thought it was going to take more than 5 seconds, then process it parallel. Well, 5 is no longer relative of how many seconds. This was built back in like the late 1990s or early 2000. The hardware and the technology that existed then, the algorithm's still the same, but it doesn't compute to 5 seconds. So it's still just an arbitrary number that we reference. So what we have found is this value needs to be something larger, anywhere from 25 to 50 based on your environment. And it's one of those things that, well, what's the magic number for me? Well, again, it depends. Again, Jonathan, the man's insane with his ability to think through the stuff and figure things out and then blog about it. So we've got another bit.ly link to a post from Jonathan where you can dig through your plan cache and figure out which queries are still executing parallel. From there, you can take a look at the SQL text. You pass it a max DOP hint and see if it will work better with a max DOP 1. So first, you want to tune the query as best you can. So without the max DOP, just is the query tuned? Do you have proper indexes and all that good stuff? If the query is tuned as well as it can be, and it's still generating, say, a cost threshold of, or a subtree cost of 50, and yours is set to 25, you pass it a max DOP of 1, and the subtree cost drops to 0.005. All right, well, this query is much better processing single-threaded versus parallel. You could increase your max DOP or your cost threshold value up to a value greater than 50. So the query optimizer should honor that and process it single, as a max DOP 1, and you've better tuned your environment. So Jonathan explains all of that. It's a really great reading, but for the most part, when we increase this from 5 up to anywhere from 25 to 50, we see a very good improvement in the client's environment. But again, it's one of those things you have to monitor and continue tweaking. Another common thing is improperly sized tempdb. So tempdb out of the box, if you install SQL Server and next finish and start pumping data into it, your tempdb is modeled after the model database. So you have a single data file, tempdb is created with a couple of megabytes, data file set to auto grow by 1 meg, log file by 10%, unless you're on SQL Server 2016. 2016 changes a lot of this. It attempts to make things a lot better, and it's somewhat better, but still has some room for improvement. So with tempdb, it's recreated at startup, meaning if your average workload grows tempdb to 8 gigabytes, and you're on a machine with 4 vCPU, when you restart SQL Server, you patch and reboot, or you fail over to your secondary node, whatever it is that you do, then tempdb is recreated at a couple of megabytes, auto grow by 1 meg. So your tempdb is going to have to auto grow over 8,000 times to get back to 8 gigabytes. So when a data file or log file has to grow, transactions are suspended until that growth operation. So you could see very erratic behavior of your instance because the entire instance uses tempdb. Another unique characteristic, which is a favorite interview question of mine, is how often should you back up tempdb? It's a critical database. The entire instance uses it. How often? Well, you can't. You cannot back up tempdb. Now, I've been challenged. Well, you could stop the service, or you could do a volume shadow copy. Blah, blah. Okay, you can't run backup database tempdb to disk, and can't restore tempdb. So what do we need to do? What do we need to do to tempdb to make it more efficient? Well, with 8 cores or less, you want to create equal size data files per the number of cores. So if you're on a 4 vCPU machine, you need 4 equal size data files. Well, how big do they need to be? Well, it depends. What is your workload? It's very difficult to gauge what size they need to be without seeing the workload. So you typically, if I'm on a brand new machine, I would create 4 equal size files, probably a gigabyte each. And then would monitor. I would set in a decent auto growth setting. I would have instant file initialization on, so the growth of tempdb would not be too much of a penalty. And then I would see what the normal size is. So if I have 4 files and its initial size is 4 gig, it grows to 12 gig, then I would set the initial size for each of my 4 data files to 3 gigabytes. That way, when SQL Server service is restarted, tempdb is created at its normal average working size of 12 gig. So if you have more than 8 cores, you want to start with 8 equal size data files and increase by 4 files based on contention. So what do I mean by contention? Well, beginning in tempdb or any database, page 1 in the data file is your PFS page. Page 2 is your GAM, page 3 is your SGAM. So when you start with a single data file, you have 1 PFS, 1 GAM, and 1 SGAM page. Well, as tempdb is being used and abused, then you'll see contention on PFS, GAM, and SGAM. PFS repeats every 64 meg within the file, but GAM and SGAM is every 4 gig. So you don't get another GAM and SGAM page until tempdb has grown more than 4 gig when you have a single tempdb data file. So by creating additional files out of the box, you're creating additional PFS and GAM and PFS, GAM, and SGAM pages. So that's why it's very important. Sorry, I'm having to pause to read an update on my daughter. All right. So I've included the Microsoft recommendation, the knowledge base article where they talk about the number of cores. And we also recommend that you enable trace flag 1118. There is a trace flag 1117 that states to grow each of the files at the same time. That is an instance-wide setting. So if you have additional files within file groups, they take on that behavior as well. So we don't recommend 1117 out of the box. However, for SQL Server 2016, the behavior for trace flag 1118 and 1117 are on by default for tempdb, which is fantastic. Also for 2016, when you're installing SQL Server, it looks to see how many cores are provisioned and will attempt to create that number of files, and then auto growth is set to 64 meg instead of 1 meg and 10%. So improvements, but again, 64 meg auto growth on a very large TempDB still isn't perfect, but it's better than 1 meg.
Tim, just for some of the people out here who aren't DBA specific, what is TempDB in terms of how is it used? So like, for instance, I would use a temp table, right? And that would use TempDB.
Right. So your spills, spills, sorts. A very popular person in the community refers to TempDB as the public toilet of SQL Server. So a lot of vile things happen there. So TempDB, your temporary objects, cursors. I mean, lots and lots of things.
So even though I create a temp database table, say, per se, and I'm doing an ETL, right? And I create a TempDB and I put a lot of data in. So that doesn't automatically grow the TempDB. It fills the TempDB up if space is available, right? If it's not used. Is that correct?
Right. Yeah. So TempDB, I mean, so it will, depending on what's using it. So if you have a spill, a sort, it's like when you do index rebuilds, you can say sort in TempDB, those types of things. So TempDB will grow to its normal working size. And like you said, if you create a temp table in TempDB and say grow it, and it takes up 4 gig of space. But when you're done with it, that 4 gig of space is freed up. So the next thing that needs TempDB usage, if it's a gig, well, you've got all this empty space within TempDB. So it's continually being filled up, emptied and reused. And say everything is being used up at the moment. So you have a 12 gig TempDB, there's 11 gig of current space being occupied. Something happens that needs 4 gig of workroom, then TempDB, if space was there on the disk, it would auto grow to create the empty space within TempDB to fulfill that need. And then as the temporary object is deleted, the ghost rec cleanup is running, those things are purged out, then you end up with all this free space again in TempDB. So it's kind of like, think of it like a transaction log where, it's used, it's freed up, it's recycled, and just reused over and over again.
To that note, I had just one more question, and then if anybody else has any questions. But so like you're in a statement and you use just a local temp table versus global. If you use global, then if you don't delete it, it's still in TempDB, right? So if you use local and you're still in that transaction, it's still there, right? If you don't ever delete it. If you get out of that transaction, say in the SSMS, right, that removes it and you don't delete it, does that remove that TempDB table local?
Okay, so you're saying within a transaction, you create a temporary table.
Mm-hmm.
The transaction stays opened. You never close it. So if you just open transaction, create temp table, load data, you walk away, then it should stay there.
Okay.
As soon as you either kill, roll back, commit, close that transaction, then it should clean up.
Cool. And I guess as far as the new features of SQL Server, do a lot of the new features use TempDB, and do we need to be worried about TempDB at all with those new features?
Like what type of features?
So like like the new column store, but I guess column store is more, it wouldn't use, say you're doing updates and deletes. I guess that use the TempDB. I'm just trying to think if there's any new features in the 2016 version that will use the TempDB more that we have to worry about.
I can't say for sure. I haven't really looked at the feature sets and been made aware of any risk or issues. I would think maybe possibly with some of the security features. I mean, I don't know if they do anything different with TempDB or not. If query store where it puts its data, where it persisted, I wouldn't think that would be in TempDB because that data is persisted for a while. So even on restart. So, but yeah, I mean, good question. Something to always be aware of and look for. I definitely know that I know there's been improvements. There's definitely been performance improvements with 2016 for TempDB.
I think we don't have any more questions. Sorry, I was just curious.
Oh, well, great question. So the other thing is, if TempDB is just I/O intensive, for your instance, then you could consider placing the files on separate disk with fast I/O. And we put if needed. There was a kind of a knee-jerk reaction back quite a few years ago when solid-state storage became a little bit more of a common thing. In the beginning, it was very, very expensive. Few people could afford it. But as it became more affordable, organizations started getting it. People thought, or DBAs thought, oh, I need to put TempDB on there. Well, if TempDB isn't your most I/O intense database, why are you going to give it the best performing disk? I've seen very, very large OLTP workloads where TempDB had not been configured properly. A single data file, it was several gig in size, and I'm thinking, oh, great, we're going to make such an improvement in performance by properly configuring TempDB. And before I went in and made changes, I started logging, looking for contention, because I wanted to be able to show them, here's how bad it is. And I could not find at any opportunity or any time during the day that they were having latch contention on PFSCAM or SCAM pages. TempDB just was not really being used. Everything was within the database. It was just dumping data in, reading data out. There was no abuse or big usage of TempDB. So if TempDB is a I/O intensive database, you could consider putting these individual files on different spindles, different storage arrays, or you could look at possibly putting them on solid state if that's what you need. But again, if it's needed. So next, after TempDB, are we really there? All right, so SQL Server Agent Alerts. Show of hands in the room, although I can't see you. How many of you are using SQL Server Agent Alerts?
Just a second, we're going to count.
Should be every hand.
About 12 out of the 40. But a lot of them, aren't DBAs. So.
Right. All right. So, when I asked this in a room, I mean, I've had from, close to 100 to, I think I've given this talk in front of 3. But, I always like to ask, because this one's kind of a why not? So SQL Server Agent Alerts provides proactive monitoring. It requires database mail, which everyone should already have database mail configured on their instance if they have any type of SQL agent jobs running, because you want to get email notifications if a job fails, right? So database mail should already be configured. So since it's configured, you want to create a mail operator to send alerts to a distribution group, and always advise a distribution group so that the alert can go to more than just you. That way, if you're on a holiday, vacation, whatever reason, you up and quit, then somebody is still getting these alerts when they happen. So what alerts do we need to be concerned about? So severity error 19 through 25 are all fatal errors, meaning something bad happened, the transaction could not complete, was killed, failed, rolled back, bad news for your end user. Error 825, which is related to an IO operation retry. You can include 823 and 824, which are IO operation failures. These agents can be created using the GUI or a T-SQL script. So if you're going to use the GUI to step through and create them, before you click create, okay, go, whatever the syntax is, choose to script to a new window. So now you have the transact SQL to generate these agent alerts for your mail operator and everything else that you can save. And then you can execute that same bit of code on all your other SQL Server instances. So with that said, you should have this as part of your standard SQL Server build. I mean, why not? Enable database mail, create the agent alerts, and then get notified when these things happen. Now I'll put together or there's a step-by-step process. You can actually copy and paste the code, change the email address, or the mail operator in it. But I did a SQL performance article on how to create all these. And then I created another article, or wrote another article about what do all these fatal errors mean, and what do you have to do to try to correct them? Now, unfortunately, just about every one of them means there's some type of database corruption, some level of corruption, and you've got to do a restore to fix. So this is another way of being notified when really bad things happen, almost instantaneously, rather than having to wait for CheckDB to run. And you can get the notification before your end user says, hey, something happened, I got this nasty error. And you can say, oh yeah, we're aware of it, we're working on it, we'll get you an update fairly quickly. So again, there's no reason why not to be taking advantage of the SQL Server agent alerts. And there's so many other alerts that you can configure.
Then we actually have a question on agent alerts.
Okay.
Yeah, hi Tim. Where I currently work, I do make use of database mail for alerts. But where I used to work with financial services, they're terrified that DBAs would send financial data outside the company, so they didn't.
Wow. So yeah, I spent 18 years in financial services, and this was never a problem. They should be able to create they should have been able to create like an Exchange user that could only email internally. So wasn't allowed to send any outbound, but you can also create these alerts to send like a net send, a page. I mean, you have additional options. Might even be able to set it up to write to a folder or something. So if you had a network operations center like a NOC or a something like a ServiceNow, where you could auto-generate a ticket that a certain severity error was created on a server. I mean, there should be other ways around not being able to send email. But yeah, I mean, I even did a stint in information security, and we didn't have concerns about systems like this sending internal email. But I get the whole outbound. So if they easily could have created that user that could only send to, like you all's distribution group. So this account for SQL Server Service, at domain.com can only send to a distribution group, and yeah, there should have been ways around it.
And we have about 5 minutes till we have the question and answer at the end here, and then we're gonna end up opening it up the SQL Server user group just to talk. So that's kind of your one. Yeah.
All right, well, good. That's perfect because I have one more slide.
Nice.
So the last topic is using balanced power savings. So power savings has a negative impact for SQL Server. It can underclock your CPU. SQL Server is not conducive to that type of behavior. And the fix is setting the power setting to high performance rather than balanced power. So out of the box, the operating system is set to balanced power. Out of the box, your hardware that you purchase from whomever is set to with power savings enabled. So you want to beg, plead, and with your systems guys or gals to disable power savings in the BIOS. So if they can turn it off there, you're golden, you're in great shape. You can talk to your group policy people and say, hey, if the server is related to SQL Server, please, please, please have a group policy object that sets the power plan from balanced power to high performance. So you cover yourselves in case a new server or a new blade gets put in, or the power savings is enabled, at least from the OS level, you're setting it to high performance. So you're kind of covering your bases on both sides. Now there's a free tool called CPU-Z that can show the clock speed in use. Now this tool, cpuid.com, download it. I would just recommend downloading the zip file. Within the zip file is the executable. Copy that to the desktop and run it. There's really no need to install the MSI because all it does is create a shortcut to the executable. Now do be careful if you type the URL cpuid.com, spell check likes to change that to cupid.com. That's a completely different website. You can't blame me if that shows up in your browser history. CPUID.com. And then other negative things that can happen with power savings is turning your network interface card to sleep. Basically, your server can no longer talk on the network. Imagine that occurring on your clustered node. Bad behavior. So with that, SQL Server's great. It's actually awesome. But a next finish install is not good at all. So you want to make sure you have proper backups, that you're running consistency checks. You want to take advantage of those log cleanups. Make sure your backup history is pruned, and make sure that you're cycling your error log just so you can more quickly troubleshoot. Make sure that you're updating statistics, that you're not relying on auto-update stats. Have proper index maintenance. Make sure you're taking care of fragmentation, and that's true if you're on solid state or spinning disk. Have proper memory settings, and make sure that you're not allowing SQL Server to starve the OS. You want to configure your max degree of parallelism and cost threshold for parallelism from the defaults. Configure TempDB for your instance. Make sure that you're taking advantage of the free SQL Server agent alerts, that's free notifications, being proactive. And then turn off any power savings so that you're not taking that 3 gigahertz processor and running at 900 megahertz. I mean, this 2016, you shouldn't be running on 2003 technology, especially with the cost of some of these processors. I mean, I've seen individual processors running in the $20,000, $25,000 range. So make sure that you're getting what your organization has paid for. And with that, I want to say thank you all for coming out, supporting your local user group, hearing me speak, and want to tell everybody that I've presented to. If you have any question related to SQL Server, feel free to email me, tim@sqlskills.com, or hit me up on Twitter @tradney. If it's something that I know, I'm more than happy to help point you in the right direction. If it's something that I don't know that I should, I'll help you find the solution, because that way we both learn together. If it's something I really don't even care about, but it's still related to SQL Server, I know the people that are as passionate about that topic as I am about backup and recovery and performance tuning. So I'll help get you the right person that can point you in the right direction.
Cool. Tim, that was awesome. Do we have any questions in the crowd that you can handle now, or?
Hi, I'm a developer, and oftentimes I'm faced with helping a customer solve an acute problem. Would you say that the techniques and items you mentioned today are not specifically going to help in that arena where you're trying to get out of an acute situation, maybe a query that's affecting their entire business or application?
So,
did you hear?
What was the first part? You're working with cubes, so like analysis services?
He's saying that in his situation, he's more of a developer, like I am. And
Okay.
so I find myself, the client or the company you're working for asks you to figure things out just on the fly, right?
Right. So a good point. So with the consulting side, and not trying to sell SQL skills, health audits type stuff, but a lot of what I just talked about are things that we look for in our standard health check, and other consultants do as well. I would say a large portion, more than 50% of clients that come to us and say, our system has just grown over time, and it's just crawling. Performance is getting worse and worse. Can you help? We always love to start with the health check first, because we can make sure that everything is configured the best way possible. That they're not having latch contention with TempDB, and the buffer pool's not starving the operating system, and everything's not running parallel, and that they're not bloating the plan cache with ad hoc queries, and just all this type of stuff. And I would say more than 50% of the people that we perform a health audit for, when we're done and they do all that remediation, they're like, oh my God, thank you so much. It is so much better. I'm like, well, hold up. We haven't even tuned your workload yet. But they get such a performance boost from statistics being up to date, from fragmentation not being there, from not bloating the plan cache, from not starving the operating system, from not having latch contention in TempDB, all those things, just from having a properly tuned instance, solves 80% of their performance problem, to the point where they're like, all right, it's good enough, and they move on. And we're like, all right, well, you'll call us back because we got you so far, but you're going to continue to grow and hit that next tipping point. But yeah, I mean, these things would still apply if you're a developer. You want to make sure that your instance is not being misconfigured. At least then you know it. You know the things that it's not. Now, this isn't going to fix your table scan, right? I mean, you still need to have proper indexing, but you're at least giving SQL Server, removing a lot of roadblocks, removing a lot of bottlenecks, so that your instance configuration isn't your problem, and that you have backups you can recover from. Those types of things. But I have additional common things that SQL Server administrators miss. Blog posts that's either out on SQL Skills or SQL Performance that goes into a few other areas. But yes, this would still apply for if you're a developer and you're responsible for the SQL Server instance. Go do all these things.
Yeah, I mean, my comment on that, and this is Joe, but as far as the production, I mean, if they don't have a resident DBA, that's kind of a bad thing, right? Is it production that they're having you mess with, or?
Yeah, it's our application.
Okay.
It's doing bad things.
Okay, so yeah.
He develops in production. I mean, come on.
So I mean, it depends, but yeah, most of the stuff you saw here, you can apply to any environment. It'd be good for you to be able to develop, to do this on like a dev or a QA and test it out, test my skills out. That's how I found out about this different stuff. But
what would be awesome is for him to say, hey, because we always say, or the developers always say, it works in development. But for you to come back and say, well, it works in development. Are your statistics up to date? What's your fragmentation look like? We're doing all this stuff on our instance. What are you doing on yours?
It's always the accidental DBA, but the company doesn't realize the value of a DBA, right? And so they want the developers to do it half the time. So, that's one problem.
Yeah.
So there are accidental DBAs out there that were developers and then they get big DBAs.
I mean, we are all accidental DBAs. Just some of us decide, you know what, we love it, and we just dig into it and we learn all we can, and we take off all the other hats and we just focus on SQL Server. But I've only known one person that went to school, and when they got out of college, they said, I want to be a DBA. The rest, we came over from either application support, application development, systems engineering, and you were voluntold you're the DBA.
Does anybody have any more questions for Tim? And then we can stop the broadcast here and then move on to just questions that people have or networking things. Again, let's give a big round of applause for Tim Radney. And those of you online, thank you for joining us. And this will be posted on YouTube, and you'll be able to watch it anytime. Thank you.